All right, I want to welcome you all to my home, the Little Residence Green Home and Solar Tour as a part of the American Solar Energy Engineering Society tour. We are hosting multiple tours of the American Solar Energy Society. You can check it out on our website. My home is going to be on it, among many others that are going to be available. We even have one coming up in person here that we'll be talking about here briefly. Before we get started, a huge thanks to our Platinum Plus sponsor, Rheem, whose heat pump water heater I currently have in my home, and I'll be talking a little bit about in the session as well, and my experience with this, along with many of our members and project teams using their 240 volts system to ensure good backup water heating, or their new 120 volt system, which my mother currently has, and I helped her get and receive tax credits for to help just easily swap out gas appliances, plug and play without having to do major electrical upgrades. So you can learn more about this more sustainable, decarbonized way of water heating, and about the tax credits that are expiring and rebates that are available over at greenhomeinstitute.org/ream HPWH. GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I am your speaker and your moderator, and we are, a small team of two taking on quite a bit. Um, like all of our sessions, this session is approved for multiple continuing education units, including the 5 pillars of green, health, energy, water, materials in place in our certified green home professional designation. AIA Health, Welfare, and Safety is pending for this session, but should shortly hopefully be approved to then make it applicable to your state-based design or contractor license. And look for the FIAS code at the end of the session, be sent to you as long as you're here the entire CU hour. And look for the ICC code, thanks to our ICCCU sponsors, Energy Smart Institute, providing trainings for our raters across the planet to get their credentials. So, welcome to my home here on the American Solar Engineering Society tour, located in West Michigan near the Grand Rapids area. As the education manager of the Green Home Institute, where I provide consultations on residential green building remodeling, new construction, it is essential that I follow my own advice and ensure the places that I also live achieve sustainable outcomes, which benefit myself and my family. And honestly, it's just fun. If I have to say, to me, this is interesting. It's a hobby, and I really enjoy doing it. As such, my first home that I bought, this is my second home, before this one, was built in 1929. And when I bought that over a decade ago, it achieved, as a result of improvements I made, GreenStar Home Certification, a DOE Home Energy Score of 10, and we dropped the HERS index from mid 100s all the way down to 65. And when we sold the home, the buyer said they really appreciated it. It didn't get any more value because at the time in 2016, just like now, home prices were going up so fast that it was difficult to garner value, but certainly was great to hear about the appreciation from the buyer about the sustainable efforts we put into the home. Now, this new home that I have, it was much newer. And so my starting point for increasing the efficiency and sustainability of the home was further along than an older home, my first home from 1929. And so I will discuss how I converted an existing methane gas heated home to all electric solar with a DOE Home Energy Score now of 10, Pearl Platinum certification, GreenStar Home certification, which includes a home water score of 6, and incorporating hybrid electric or plug-in electric transportation, and how you and your clients can also achieve these kinds of results both in your improvements or ideally during new construction, thinking through these things so you don't have the same problems my house had. We'll provide a high-level systems approach and overview of home improvement, including what I did, lessons learned, and things I wish I had done differently. So again, welcome to my house. Thank you for at least virtually joining me. I wish you could be here in person to hang out, but I appreciate you nonetheless coming virtually. My home was built in 2002, or I think, or at least right on the end of 2002, finishing in 2003. And as you'll see when we review the energy audit results, it was constructed slightly better than the energy code in terms of the wall assemblies. However, it definitely included some water management issues related to the design and durability of the home. I purchased this house in 2016, and just as I personally advise everyone to do when they go to buy a home, is get something that we call a full green home inspection or whatever local equivalent you might have available to you. As well as within that inspection, including a home energy score to be done on every existing home. We also did have a traditional home inspection done since our green home inspector at the time was not formally a licensed home inspector. However, if you can find someone with all these credentials all in one, green home inspector, and home energy score assessor, um, even better, right? Have it all in one. And in many cases, a lot of these things are all the same, 90% the same information being reported. The green home inspection process reviews the energy efficiency, health, durability, water conservation, solar, and electrification opportunities with all of our trained assessors. So what did we find? This report is our DOE Home Energy Score. On the left side, you'll find the information of how we assess the home and its current condition over here. And on the right side, you will see the end results after my project was completed in 2021. As I mentioned, a home energy score of 7 is quite typical for a home built at this time, and most new homes would probably fall into an 8 or 9 range under today's energy code. Although for new construction, we recommend an energy rating index. This tool, currently, I did not use the energy rating index for my home like I did on my previous home. And as someone just posted in the comments, yes, if you can do a passive house review on an existing home, even better. So good, better, best, good home energy score, better ERI, HERS rating kind of thing, energy rating index, best being a passive house review. Again, it all comes with time, cost, effort. So this is the path I took, given the resources and time I had. But certainly, the more of an analysis you can put within the green home inspection on the energy side, going all the way up to the passive house level, it can be done, and certainly should be done if you have the resources, time to do it, to be sure. So, what did we find? Again, here's some basic information about my home in regards to what was going on. The appraiser put together this nice little map, but now we're trying to train our green home inspectors. You can literally go in with tools and literally map the whole home with a smartphone, and it will generate a floor plan. You should always be walking away during your inspections with a floor plan generated. But this is the one I pulled from the appraisal report. What I have, my home is a bi-level home. So you walk in and there's the landing, and then you can immediately proceed into the laundry room, or you go upstairs, or the plan I don't have here, of course, below grade right here is the footprint of the basement, and then there's kind of a small crawl space underneath the laundry room. From an accessibility standpoint, this is terrible because you're coming up here, you've got a step here, and then you come up here, you come inside, more steps, either going up or down, completely inaccessible to somebody with mobility challenges. So already an F minus for this home, terrible for inaccessibility. Thankfully, I don't have mobility challenges, but people do, and things happen. You might break a leg, very terrible for accessibility. So something that can be designed out from the new construction standpoint, do not build these split level homes. Awful. But anyway, from the green home inspection standpoint, we got a 978 on our CFM, and that's 3.95 air changes per hour. Built in 2002, that's just slightly below today's energy code here in Michigan. So again, hats off to the builder on that. It was tight. And you know, as time goes on in a home, they get less tight. So it must have been even tighter when it was built, is my guess. So here's just some of the energy rating scores you can see as a result of the home energy score. It tells you your MBTUs per year, your EUI of energy use per square foot, and it breaks it down by electricity and methane gas usage. Again, when I bought the home, it had a lot of gas. Again, just some basic information here about the roof, how big it is, what the R value is. R value, again, of attic insulation, R38. That's today's energy code. It's not the best, but that was built several years ago. So again, hats off to them. They didn't carry the energy efficiency necessarily down to the foundation levels, though. And then they got R13 in the walls, which again, that's currently Michigan's energy code, not the new one we're trying to pass, which is R21 or so, but still pretty good for, predating the energy code. Um, the energy score also kind of gives you an evaluation of your windows, which will impact your energy rating. Double pane, low insulating vinyl windows, which again, I think were pretty standard back then. I don't know if single pane was still allowed back then or not, but pretty good low E insulating windows with a decent U value for that energy code. Now, the biggest concerns that I had about the house were less, though, about energy conservation and more about health and safety, which is reflected in the mechanical portion of the home energy score assessment in the green home inspection we did. Unsealed ductwork, ducts and pan joists, these reduce the efficiencies on the HVAC system, which usually means poorly designed systems that lead to discomfort, high humidity, VOC exposure, and at worst, carbon monoxide. So you can see the efficiencies of the home were just basically, legally allowable efficiencies of the natural gas, methane gas water heater, methane gas furnace, 70%, and a 10 SEER air conditioning system, which actually surprisingly seemed to be undersized for the home, or at least over the years wore down and lost its ability to effectively cool the home. It was always constantly running. So sometimes that's a good thing, but it couldn't keep the home cool at the hottest times of the year. And you can see again, here is this is where we were at when we scored the home, when we bought it. And this is where we will show you how we got to with the upgrades. So besides identifying HVAC and plumbing inefficiencies, one of the first things done during the green home inspection was a combustion analysis of the water heater, which was a naturally drafting and had passed the test. But, these tests can pass one day and the next day they can fail. Thankfully, ours seemed to operate okay and was installed properly, even without a formal inspection or combustion analysis. You can tell if it's going to be a concern when you buy a house by the gap right here. If you can see through this gap, this tells you that the water heater potentially could spill out, especially when you turn on a range hood, which we didn't have, and I'll get into that. It could cause backdrafting and cause pollution, carbon monoxide at worst, to spill into the home. So you don't want to have something like this when you find it. So, it worried me to live in a home like this. So, although the builder may have done a good job from an efficiency standpoint on the building shell, they did not perform well in terms of water management details for this house. At first glance, there are no gutters. Instead, water drains directly to the foundation and splashes over here and is rotting this entry door. Additionally, plantings that surround the house around the foundation create moisture and pest problems. The other thing is these little tiny eaves up here, these little architectural designs up here, made in the sections of the home on the right side in the front, as well as you can see a few more of these little eaves here in the back. They now have darkening spots with algae growth underneath them that has to be constantly cleaned off. And also, this house either has really no grade or in some cases a negative grade back into the house as far as water drainage. Now, to be fair to the builder, they may have gotten a soil site analysis done, or maybe they just got really lucky. But using the USDA's Web Soil Survey tool, we were able to determine the hydraulic soil group A, or soils having high infiltration rates even when thoroughly wetted or consistently chiefly of deep well to excessively drained sand and or gravel. These soils have high rate of water transmission and would result in a low runoff potential. The owners who sold the home confirmed this by noting that they have no sump pump in the sump pit that they had, and they never needed it because they said they never had any water issues. And I have confirmed it living here that the water drains very fast. It's very draining around the site. And so the gutters and grading, as well as some of the foundation water management practices, probably were not necessary. But these are things you need to figure out on a home, not just get lucky about. Or it will cause, in our case, where we live, what we call Michigan basement syndrome, moldy, mildewy basements. I have family members who have those. I've had them growing up in them. Very nasty stuff. But let's continue on with the durability problems. The green home inspection revealed very slow roof leak and some poor shingle installations or flashing. We had the owners who were selling it to us, hire a contractor to caulk and seal and temporarily repair these areas before move-in, as the roof was still within its warranted lifetime. In addition, because we are now planning a new roof, several roof agencies have quoted me and said clearly the shingles did not last to their full life and expected warranty. Now, we'll also be spending a lot of the time talking about cool energy efficiency technology and green features. The reality is that most homes are suffering from this poor water management practice, and it's not trendy to try to fix these. It doesn't save on utility bills, doesn't reduce carbon emissions. Rarely do programs even want to pay any money. Any kind of government or utility program rarely pays any money to fix these things. And sadly, they're often overlooked in new construction and renovations because people just assume these water management practices are getting done. And it's really scary to think that they ultimately are not. Now, the green home inspection also revealed that the home did not have any carbon monoxide detectors. There was a lot of incandescent lighting, but the good news is the stove was already electric. Some people probably would hate that. However, the microwave above the stove, it was not vented. It was recirculating, just spitting pollution back into my face if I used it. So some of the first initiatives we took upon ownership were to immediately add a low-level carbon monoxide detector to the home in the utility room until I could swap out all of the fire alarms, which were outdated anyway, and the inspector recommended getting different types of fire alarms that would be safer and more effective in an emergency. We also updated everything to mostly all LED lighting. We added low flow bathroom down to 0.5 gallons per minute immediately to reduce water consumption and energy consumption. I also wanted to try to attempt to have better air quality. Um, so I immediately upgraded the 1-inch MERV, which had a MERV filter of 4 in it, in the HVAC system to a MERV 8. And that also had a certified allergen standard label on it. And we flipped the furnace fan to go from auto to on, and so it would run when even no conditioning was being called to continuously filter the air in the house. And I ran both of my bath fans all the time, so I essentially had continuous filtration along with an exhaust only strategy, which would bring us up to code compliance, at least today's code, of probably somewhere around, 80 CFM or so of air being pulled. Of course, at the time, I wasn't aware that running the filter on an auto on my house was potentially adding more excessive humidity to the home, especially in the shoulder seasons. And I had no the thermostat I had was dumb. It had no humidity sensor on it. Um, but the good news is the air conditioning was undersized, so it was probably doing pretty good keeping the humidity out when it could keep up in the summertime, which it often didn't. But the other issue is that the ducts were leaking. They're panned through the joists, making them even harder to distribute heating and cooling to the main floor, causing imbalances of temperatures in the floor that's further away from the utility room on the second floor and had bigger facing west windows that got pounded by the sunlight in the summertime, especially overheating in the summer. And so this filtration strategy was just a placeholder until I could do my whole home improvement project. So let's start, as much as you want to plan everything, and I wanted to do everything all at once, that's not the reality of home ownership, is it? In late 2017, the clothes washer broke. which at the time was a top-loading, very inefficient, non-Energy Star certified clothes washer. So it was easy enough just to replace it with a front-loading Energy Star certified clothes washer. The washer also has a time of use setting, meaning I could load it up and then turn on the washer, have it automatically turn on at a later time when the grid power is cheaper, cleaner, and or in the future when I brought in solar, when the solar power was running. One thing you have to remember for maintenance of these front-loading washers is though the lip in there catches a lot of water, and if you keep the door shut, it will mold and mildew. So one thing you have to do is clean it out and keep the door open after use. And also the nice thing about these washers is they have a self-cleaning mechanism, so they'll tell you when it's time to run that, and I noticed that cleans it, very well. So in 2018, I got really lucky. Most people would consider this bad luck, but I considered it good luck because my methane gas water heater that I showed you broke down. And so it gave me a really good excuse, even though I was again waiting to do a whole home improvement later, which we'll get into. It gave me a good excuse to swap that gas-fired water heater out with a heat pump. Um, and so I went ahead and purchased a Rheem Prestige Model 3, given, that seemed to be the easiest one to obtain and the most one that was available, across the US at the time. It has a 240 volt heat pump water heater in it, and so it has the backup resistant heating element. This particular heat pump, also has leak sensors, energy monitoring app that's pretty cool on my phone, and the ability to control it remotely through that app, allowing me to adjust the temperature and track usage over time. The way that the heat pump works, if you're unfamiliar, is on the left there is the top. So you need to make sure that you have it placed in a large room. And I had a large utility room that I keep the door open for cats to come in and go. And so there's plenty of space and volume in that room to suck air into it. And then that brings in the heat. And then you can see on the right side, that's the other side, that exhausts that heated air, much colder, much colder, drier air. And then it takes that energy in through refrigerant and then uses it like your refrigerator, but in reverse, heating the coils around the tank and heating it up to, nearly 400% energy efficiency. Now, when I switched out the gas water heater for the heat pump, it improved my home energy score from a 7 to 8. I reran the analysis. It reduced my overall energy use and it reduced my carbon emissions. But there was no cost savings for my operational because electric rates are so high. Gas rates are unfortunately, and good for a lot of people who are financially struggling. Gas rates are at least artificially low still to this day. And so it was a wash. Super efficiency, electric savings, but electric costs more. So I saw no total change. Again, for me, it wasn't about the operational car or the utility bill savings. It was about having a device that's cool, having a device that works, and having a device that isn't going to, lead to carbon monoxide poisoning and other problems in my home. In order to maintain the efficiency of this water heater, I keep it set at 130. I previously had it at 140. It has such a long run from my house to the other devices that it takes so long for that water to get there. It's already cooled way down anyway. So setting it to that higher level doesn't make a difference. Um, and so typically I also have a time of use setting set up where it is set at 120 degrees during the 2 to 7 period. So you can see when my energy monitoring app, you see that big gap. And typically I don't use it during that time either, but even if I did, it usually, because the temperature lowers on it, I try not to use hot water at this time on the weekdays. Even if it did, typically it still avoids pulling power because the temperature turns down 10 degrees anyway. So, it's not trying to heat it up to that higher level. Sometimes it will, but I usually avoid that. A lot of people recently complained about sound issues with several models and brands. I can say and show that my sound is fine. With this being in the utility room and away from living spaces, I heard, I don't hear it as much. I heard most of these sound issues are on the newer heat pump models, and I heard now that they've recently been fixed. But if you're concerned, what's really nice is that this particular brand has the Generation 3 that I have still available. So apparently you can buy that if you're worried about the sound. And so I can tell you this one is just great. And I have sound quality measuring apps, which I'll talk about that I use to verify the sound. As far as maintenance on these systems, it's a little bit more than a traditional gas-fired tank water heater. Um, it probably costs about $200 per year for a professional tank flush, which you actually need to get that done on any water heater, especially tankless water heaters, or those will seize up. Um, and then you also want to blow out the condensate line, which can be do-it-yourself friendly. I stay away from that. I don't want to, I just don't feel comfortable doing it. But so we just have a professional come, flush the tank, blow out the condensate line. And what's nice is that the condensate line is tied into my heat pump, which I'll talk about, my dehumidifier, which I'll talk about, and my humidifier. So it's all tied together, and so it's a once and for all flush that happens every year, gets them all done. Um, and then maintenance I do myself is I have to pull this filter out, switch it to all electric mode. I keep it in all heat pump mode, and then I just, wash that off in the bathtub, let it dry, and then the next day turn it back on to heat pump mode and put it in there to get the dust out of that filter that's processing all that air that's coming in. So up until now, most of everything I did was incremental, as is typically done on most projects, making small home improvements here and there, swapping out appliances when they go bad. But starting in 2019 is when I really began my whole home project planning. This is what I would argue needs to be done across the majority of our existing housing stock, and ideally should be done in tandem with the home purchase phase when you have a lot more borrowing power and leverage, um, as well as the ability before you move in to reduce disturbances to your life and family, or to help your clients reduce their disturbances. Making all of these improvements during move-in and funding it right into and financing it right into the purchase of the home. I understand there are many challenges and limitations to doing something like that, but I do want to at least suggest we try, and I don't feel like we're trying very hard to do this as we, buy and sell homes. Um, but I think there are ways we can overcome this, and that's why we're out here having these conversations. So I began putting my full work scope together and encompassing all my improvements that I wanted to make to the home, including full electrification by updating ventilation, water systems, and adding solar to the house. So I began to evaluate all my choices at the time, including just updating my furnace and AC to be more efficient, be more modulating, to do a new modulating furnace with a dual fuel heat pump, removing the furnace and AC entirely and replacing them with an air source heat pump. And spoiler, that's what I did. Or ideally, going with ground source heat pump geothermal systems. Here you can see that we ran Department of Energy Home Energy Score analysis software. You can do it with ERI, you can do it with Passive House, whatever. Use the software, run an analysis on your improvement. And so if all things were being equal, just looking at the HVAC systems, what would it look like? How would my home energy score change? How would my MBTUs per year change? My kilowatt hours and therms change? And, inflation is, of course, a super wild card here, sadly, but factoring out inflation and keeping it a 2% annual cost improvement with an average cost of Michigan utility rates, this is where we would land as far as operating costs, again, on the HVAC, which are going to be one of your biggest impacts to operating costs for a home improvement. Um, and again, my house didn't really need much weatherization. So if you have a home with weatherization, this is going to be a different conversation you're going to be having, but same kind of analysis. So you can note that just improving the gas and AC to more efficient had the lowest operating cost, But the ground source heat pumps had the second lowest operating costs, along with the biggest energy score boost, meaning lowest energy and carbon usage. The data showing the dual fuel costing more than the AC was a little bit surprising to me, but that's because it's based this when we ran this analysis, it was based on some outdated and inadequate data within the home energy score tool, not being able to model cold weather climate systems. And so I believe now that that's been corrected, using a comparison like this, you should get better results in your cost savings with dual fuel versus just straight out AC. You'll definitely get better carbon and better energy score results for sure. We're seeing that, on what we're modeling. So given the sweet spot of cost, energy usage, electrification, um, and winter resiliency, I was very convinced I needed to go ground source heat pump back in 2009 as part of my initial plans. So I went out and got a lot of quotes. And you can see from one of my quotes, the schematic here of my ground source heat pump bid, which includes the ability to handle heating and cooling, but also hot water. But given I had just gotten a new heat pump water heater, I was less excited about the hot water, another standby water tank being added to my house and taking up more room in my small utility room. Um, and I just didn't really want to invest more into hot water. So that really wasn't that exciting to me as it might be to someone who's swapping straight out from electric resistance or a gas-fired heater. Also, at the time, there was a 23% tax credit available for ground source heat pumps. In addition, I wanted to incorporate solar power, which also qualified me for another, potential tax credit as well. That was before the 30% tax credit was enacted in the Inflation Reduction Act. And so I was trying to strike a balance between a ground source heat pump system and a solar project. And so you can kind of see this all kind of came together at once. At the same time, I was getting quotes to put solar all over my house. I was getting ground source heat pump quotes, and I wanted to have the best of both worlds. As I went further down the path of evaluating ground source heat pump technology and getting quotes and bids, it was clear that the cheapest system would be going horizontal out into my yard. And that would have killed a lot of trees and didn't even consider the cost. At the time, I didn't even think about the cost of tree removal. That wasn't even in the bid, which I know typically cost into the thousands. And it also got near this little X here, which is where my well water head was. So that was concerning to me as well. As I think about it in hindsight, I'm not even sure the tree removal could be on the quote, and it probably didn't show up on the quote because it probably couldn't be part of the cost of the tax credit. Um, and so, however, that didn't matter because I didn't consider it at the time. And I had no interest in killing trees, which, harms carbon emissions and wildlife and all that. So my only other choice, and you can still do this, is you can bore down vertical with a ground source heat pump. That would have been actually made the system more energy efficient too. I still believe that that's true with how ground source works, but it cost $5,000 more to bore vertical, which doesn't really make sense. But that's the way it is. And so, we were looking at a $35,000 system, which was just excessive. So this was all occurring at the same time that as part of my day job, I had to be educated on how to help make homes more green and sustainable. And back in 2018, electrification was becoming all the rage. I was learning about air source heat pump technology I'd never heard about before. I was learning about cold weather climate certified models. So I started to pivot to getting quotes for full cold weather climate air source heat pumps and analyzing my utility savings within that home energy score software. And as you saw from my previous energy modeling slide, the projected energy use and reduction and cost savings difference between the ground source and air source heat pump, at least for my home, using the home energy score. Again, those are all caveats. It's my home using the home energy score. You might get very different results using a different tool or using, different brands of systems, especially in the year 2025. I was seeing very minimal cost savings in the ground source and carbon savings versus the air source cold weather climate system. Um, and I wasn't sure I would even qualify for the tax credit for the ground source. I'm pretty sure I wouldn't have. I may have, but I didn't, well, I didn't know. I think I probably would have now in hindsight, but back then I couldn't factor that in. So, the other thing is I wanted to make sure I was showcasing the future of technology. And so I really believe that the air source heat pump being cheaper, more flexible, more attainable, uh, or even being able to be easier as a dual fuel system, I thought this was likely going to be the future of HVAC. And so that's what really also helped influence my decision of deciding to move on from ground source to air source heat pump technology and replace my methane gas furnace and air conditioning system. The other thing that's cool to know, you have, as of this webinar, if you can get an air source heat pump system, you might qualify for a $2,000 tax credit, but that ends at the end of this year. Or there are home energy rebates in many states that could qualify up to $8,000 off the top of these systems. I didn't get any of this stuff. And am I bitter? Am I angry that I didn't get any of this stuff? A little bit, but you know what? I'll get over it. So I'm still happy to promote these rebates to others, even though I didn't get to benefit from them. The other thing I wanted to mention is that this system has no electric resistance backup. I decided not to have it installed. And I will promise you that even during the 2021 deep freeze cold snap that got hit with, the system never had any problem keeping up and keeping my home, cozy. It didn't keep up to the temperature set point that I had for a couple hours, but we didn't freeze to death. And that was just for a couple hours, like on one day during the coldest heat snap. So as long as an HVAC contractor communicates, hey, this might happen, that's okay. But, being afraid of it or ignoring it, those have to be part of the conversations. When I settled on the heat pump, air source heat pump, I decided to set out and complete a heat load calculation for my house. This was involved in taking my home energy score assessment data from the GreenHome inspection, along with my blower door numbers, and then running them through an approved Manual J software. This software I used is open source, do-it-yourself friendly. However, if I were to do it again, I might also now use a web-based utility bill application such as Thermentor, which we've featured on our webinars before, to figure out the usage. You can see the difference here, and it's just clear that, Manual J software always tends to size a little bit higher. On the heating load, we were at about 24, whereas if I was using my utility data, from 2017, gas and electric, we're at about 19 MBHs. And so the other thing I would recommend now is the BPI 24 audit process, which incorporates actual energy usage of the home, the utility bills, and a home energy score type-like assessment all in one, and can then also evaluate a predicted energy or a predicted load calc. And this BPI 24 audit may be free and part of home energy rebates inspection processes in your state. I didn't have access to that back then. That's what I'm suggesting you use, now. So as I got those budgets aligned and the air source heat pump system bid with the HVAC contractor, my next goal was to remember the V in HVAC or ventilation. And so to look at replacing my aging bath fans with newer Energy Star certified bath fans, one that could get up to 100 CFM, as well as installing a range hood ventilation system to exhaust cooking emissions outdoors. On the left here, you can see another really great do-it-yourself friendly tool that is now owned by Pacific Northwest National Lab called RedCalc. This includes the ability to enter in the blower door data we got from the GreenHome inspection and evaluate my ventilation rates. I used at the time ASHRAE 62 2016, which is what programs like LEED and GreenStar call for, and it allows using the infiltration rate of air leakage from the blower door test. I determined at the time I only need 52 CFM of continuous ventilation, which is like the equivalent of my two bath fans running at 25 to 30 CFM to achieve the ventilation rates for healthier air using an exhaust-only strategy. However, in the summer of 2020, all of a sudden, at least from my perspective, air quality monitoring became easier to obtain and became more interesting, I think, because of COVID. People were all talking about air quality. And so I started experimenting with these sensors uh, in my house, starting that year and even before then. Um, and so with multiple different air quality sensors around my house and how air is working and flowing in my home, I found that, monitoring the air over the years gave me useful information on what works. And, while I cannot speak directly to the accuracy of any of these monitors, I can say that they respond and change and show results based on what is going on in a way that is consistent with the current situation in my particular home. And others I've spoken to say similar things. I'll be doing further training webinars on this topic for my IAQ results and others that we've been talking to, over the years. But again, in 2020, I got a hold of my first monitor, my first whole home, all holistic monitor that did real carbon dioxide monitoring. Before that, I had one that I tried to guess the CO2 based on total volatile organic compounds and TVOCs in the air, and found the ones that did those kinds of guesses of CO2s were not accurate. I did some experimenting and it showed significant levels of CO2 in my house and the differences of how they were versus when we had all the bath fans running. And I tested this when a heat wave was going on. So we had all the windows closed for about a week. So we kind of suffered with very stuffy air in our house in the summer of 2020. But I really wanted to see what my CO2 emissions would be, both with bath fans not running and with them running constantly all the time. And so, what we found was about 1,200 to 300 parts per million of CO2, which was putting it into the red. And then the next week, we ran the bath fans at full speed and got it down to about 800 parts per million of CO2 in the main living space. And since my home is now less than 4 air changes per hour, right on the borderline of what a tight home is, I thought it'd be important to throw in a balanced ventilation and not just use the bath fan strategy during my home improvement project. So here's an overview of my ventilation systems in the home. I went with two Panasonic Whisper Green bath fans that could be modulated between 50, 80, and 100 CFM as needed. A hood range that exhausted outside that could be modulated between 100 and 400 CFM. And this hood range was tied into an air quality monitoring system on my stove. And at the time when particulate matter from cooking spiked due to whatever's, burning something or just the natural events of cooking, this would actually turn my range hood on if I forgot to turn it on while I was cooking, and it would elevate it to higher levels if those PM 2.5 levels rose up, and it would exhaust it out all on its own intelligently. It's called smart ventilation. This thing would also turn on, like if I kept my window open and wildfire smoke or the neighbors burning, having a fire blew into my house, all of a sudden we're like, why is the hood range running? Oh, there must be wildfire smoke in the area, or the neighbors are burning somebody, or some nasty truck drove by. And so it would actually turn on. And because it was sensing that, or if we blew a candle out, if you don't know this, when you blow a candle out, that's when the PM 2.5 levels typically spike. So it would turn the range hood on. Sadly, Panasonic has since discontinued this model that I had, and that even shut down the system I had, so it no longer does that. But I can tell you for several years it worked. And so now there are other manufacturers have taken up the mantle and have these smart ventilation systems. So I highly recommend them. Um, I also ended up getting a radon system because my air quality monitors were showing concerning levels of radon near and above the thresholds of the European Union and Canadian levels for lung cancer prevention, lower than what the EPA advises. And so I, I wanted to just to be safe, I was trusting more in the EU and Canadian numbers than the US EPA numbers. I also got a MERV 16 filter for my main HVAC system and a MERV 13 ERV intake filter. And this helps reduce the particulate matter in my house from outdoor air, wildfire smoke, and even cooking if I turn it up for recirculation. And my VOC or my CO2 or my monitors, prove that. They verify that. Finally, my house was very dry in the winter, falling into the 20s of humidity based on my air quality monitors and based on my cracked and bleeding hands while I washed the dishes. And so I got a whole home humidifier, which seems to keep it in around 35% if I crank it at full speed in the dead of winter. Still dry, but more tolerable and, helps reduce allergens and viral transmissions. Finally, the main system finally the main star of the show, the ventilation system that I have in my house is a Panasonic cold climate energy recovery ventilator, which is 100 CFM, but now they have them up to 200 CFM. And it's ducted into the existing furnace system, and te we tested it at 92 CFM after it was installed, which is pretty good, especially because it's ducted directly into the HVAC system and not a standalone, which is highly advised, especially in new construction. I was also able to reuse the gas dryer. I used to have a gas dryer. The exhaust port for the exhaust for the dryer, not the gas part of it, but the dryer exhaust. I was able to use that for the ERV exhaust, so recycle that hole in the wall. And then where we decommissioned the incoming air you need for combustion for methane gas, water heaters, and furnaces, we use that for the intake of the ERV, and then we shut down and sealed the other two, probably further allowing my house to, be more airtight. And so we recycled that as well. And so, maintenance for the ERV has been pretty easy, just cleaning off the intake duct system when it gets dusty every month, changing the filter every as needed, and then vacuuming it out the inside with a light brush every time I change the filter and open it up. Um, every new home and every major renovation with air sealing should definitely have an energy recovery to act as the lungs of the home. Duct design is very important for heating and cooling, and we were limited. We couldn't change the ductwork, even though it's not great ductwork. It's all buried behind the drywall. And actually, this was one of the reasons we couldn't LEED certify the house, which I wanted to do, was because you can't have pan joists in the ducts. But all my ducts are behind drywall, and I, didn't want to tear out drywall, didn't want to pay for a new duct system, didn't have the budget to do it. I think it should be done on all homes, but it's expensive. But also, as far as ventilation, where you can access ductwork, this is very important. And here's a lesson learned for me. Our HVAC contractor installed a rectangular ductwork, and so what we noticed, first of all, was the sound. I could hear, and I was looking at the zone ratings of the hood range, and I was using a rating app on my phone, and I'm like, these zone ratings are way above, what it should be. In addition, when they tested the ventilation, it was below what the setting was. So if it was set at 100 CFM, the output was far below that. And so we were getting not good ventilation. We were getting loud noises. I think what they were trying to do, I understand, is they were trying to make it from an aesthetic standpoint. They were trying to hide this duct, which I get it. Clearly, this one down here that we fixed it with, this round duct, a little less hidden to be sure. But once we realized what was going on and we had it fixed, we dropped the first tier level, the 100 CFM level, from 64 decibels down to still pretty high for an open floor plan living room, but down to 50 decibels on that, and of course also improved the ventilation take to ensure the pollution was removed. So long story short is duct design is very important, and round shapes typically flow air much better than rectangles and square shapes in many regards, at least especially in regards to this short run system here. And speaking of noise, which again is a health issue, right? Loud noises can cause all sorts of stress and anxiety and other health problems with people, and it often gets left out of green building. But what I did was before they tore out my furnace in November 2020, I did a sound quality monitoring of it just to show you how loud this thing was. 58 up to 56 decibels on average in the main living room, far away from the furnace, just soaring like a airplane taking off. So once we got the new heat pump installed, we were down to around the 35, which is the health recommended level in the sleeping area. 40, I think, is the level in the living area using our decibel app. So much quieter, much healthier sound level as well. Another aspect of sustainable GreenStar home improvement is water conservation. And despite being next to the Great Lakes, our region here in West Michigan is facing severe drought. And for those on water bills in cities, those are going up exponentially. And even though I'm on groundwater here and don't directly pay a water bill, that actually means I have to pay for the energy every time my well pump has to run. So that burns energy, burns carbon. I show it on my energy monitoring app. And so I don't want to aid further in the additional drawdown of the aquifer. And even though I don't pay that water bill, it was important that I reduce my water bills. So I went about and updated during my home improvement project my toilets, shower head, sink, dishwasher. Um, and the bonus about the dishwasher was, again, open floor plan home. You're talking about a loud dishwasher. So we also got an Energy Star certified and a quiet low dBA dishwasher. It's actually running right now as I speak. Um, and so, very quiet, hard to hear, isn't interrupting this webinar. I'm not very far from it. So again, it's a win-win-win. Less water, less energy, less health impact on my sanity of loud noises. The other thing about water is because I do not pay my water bill, I have no idea about how much water I'm using. So I added a device that tracks my water usage in real time and has leak sensing and has a shutdown protocol in place and sends out alerts when water is going flowing too long. And so it even detects the incoming water temperature for my house. I highly advise water tracking at this level, even for people on municipal water, because sometimes your municipal bill, I know when I used to get one, it was coming every 3 months. I got little information on my water usage. And if you think about it, these water meters act like an electric smart meter, giving you real-time data, helping you ensure that you're not being overcharged for water, you're not wasting water, and potentially preventing leaks, which can cause mold and mildew and other issues. So one thing you need to know about the GreenStar Home tool is that it's something has the water score built right into it. And so you can use that to assess your water usage and plan improvements like I did. In this case, you can see all my old water usage devices here in this column, putting those in when I found the home in 2016. And these old water devices resulted in a home energy score around 1, where you need a 2 to certify. And this resulted in a projected water use of 48,000 gallons of water per year. Now, after I made all those upgrades we discussed, you can see here, I added a single flush vacuum assisted 0.8 gallon per flush toilet. I added a dual flush, 0.95, 0.5 on the low end, flush toilet in a different bathroom. And if you average those together, you get about 0.725 gallons per flush, resulting in 50% water savings over what I currently, or the baseline water usage of a 1.6 gallon per flush toilet. I've been using these vacuum assisted technologies in both my previous home and this home for over a decade now. And they work great. No issues, no problems, no backup because they have vacuum assisted technology in them. you have to watch out. If you get these low flow toilets and they don't have that, they can get backup issues. Um, I also got my shower head down to 1.25 gallons per minute, which is probably about as low as you want to go. After that, you can start to have a lot of issues, especially if you have low pressure. You want to check your pressure. I got 1.5 gallon per minute in the kitchen, which is about as low as you want to go. Energy Star clothes washer in 2017 and the Energy Star dishwasher. And again, I got the leak detector to verify I had no water leaks. So overall, that brings me up to a home water score of 6, which actually qualifies me at the platinum level for GreenStar. But there's other reasons I didn't make it to that, of course, not yet, but I'm working on it. And that puts me at an estimated about 26 gallons of water per year. Now, I did not factor in my outdoor water usage because this home, when I found it, had a whole sprinkler system and I just left it alone. I never used it. And my home is surrounded mostly by Kentucky bluegrass, which uses a lot of water here in Michigan, but I don't water it. I just let it brown out. I don't care. And the other thing is, though, half my home is surrounded by some drought-tolerant plantings that I added, some food gardens, and a lot of just naturally wooded areas, so they don't need to be watered. So, given that, I think if I were to run my analysis, I wouldn't get a great water score. But the fact is, I don't water it. We have to assume people are watering it. Always, most people are, but I don't care. The home is kind of hidden, from the road. So it's, not in a situation where we have neighbors who are going to report us for not watering our lawn, which can happen places. If you are going to be doing it, that's part of my project improvement plan is to um, is to get test out some drought tolerant grasses that function and look just like standard Kentucky bluegrass. So I saved solar for last because it's one of the last things you should consider, in my opinion, when you're improving a home or building a new home. But it's no doubt a huge cost, effort, energy, and carbon saving reduction as part of my project. And now it's becoming more important for resiliency. Um, when I received many solar quotes and bids, but ended up hiring a larger Michigan company called the Green Panel, who oversees, I think, most of the Lower Peninsula, and had them put on, when it was all said and done, a 3.96 kilowatt hour, a kilowatt, not hour, kilowatt Panasonic solar Enphase microinverter system. Uh, on my garage facing mostly south. Since the installation in February 2021, I have generated 22 megawatt hours of solar power, with 54% of that going directly into my house, 24% of that going into a battery, which I'll talk about, and 22% of it being sent back to the grid directly. Um, And I have net metering, so as of now, that's a benefit to get paid the going rate when I send power back to the grid. But that is changing for me. Overall, my solar projections from the green panel seem to be dead on. They're right on with what they said I would be producing. So it's always important to make sure you work with a solar installer who knows how to make good projections, because it'll probably be part of your financial planning to save your utility bill, which was a big part of mine, and I'll talk about that. But I have to say, I'm very pleased with the system, the work they did, and going solar here 5 years later. Um, as I mentioned, my initial goal was to go all solar power and load up my whole house. But that goal came in, butted heads with, originally a geothermal system, but now uh, with, resiliency. My concern was I kept going through lots of power outages, and I was really worried about the fact that the solar, was worthless um, when the power was out. It can't run when the power is out, and that's the case across the whole country, to protect the line workers. So because I was having these, because I was having this, I decided to shrink down my solar project and incorporate a battery. The other thing that encouraged me to go battery was the ability to guarantee staying off the peak time with our new time of use rates that were coming from 2 to 7. And so that could guarantee in the summer hours from June to October, June, all of September, that if I use power in the middle of the day, I would be charged a lot more for it. And also, I'm on a critical peak power plan where when there's a heat wave, I get charged 10 times the going rate for electricity. But that comes with a benefit of less costs at night and in the winter. So there's a trade-off. But so having the battery allows me to stay off that peak time easier than if I just had solar and gives me resiliency when the grid is down. So the battery I got was a 3.5 kilowatt of usable energy capacity, 10-year warranty, 5 kW of continuous power, and a 7 kW of that sort of peaking power. The battery has real-time energy management tracking and usage, so I've been able to use it over the last 5 years to also understand how much power I'm using, when I'm using power, where I'm using power. But unlike some other devices that you can tie into your main panel, it doesn't tell you exactly down to the plug level where you're using power. But it does give you real time, like almost to the second energy usage. And so you can know if a device turns on or off. Like you can start to get a sense and write down, what's using power in your house to be better educated and informed to make better decisions to reduce your power loads and save money ultimately. It also tracks and differentiates whole home energy usage, energy coming and going to the grid, energy coming and going to the battery itself. The data reported on my battery pretty much matches what my smart meter for my utility does. But what's really nice then is if the utility wasn't being honest in their reporting or inaccurate or they were making a mistake, I would have my battery information to kind of challenge that assumption. So the battery has a time of use setting, so I plug it in and my costs, I can plug in my costs to buy and sell, which are very different throughout the day in the summer and night, and very different in the wintertime as well. And so I can plug all that data in. Um, as you can see on the left side. And I can balance my cost savings with staying off peak, with reducing carbon emissions, with being grid resilient if the power were to go down. It's kind of a balance. It's a balancing act, right? And so the sort of intelligence of the system helps you do that. And if you're not an energy nerd like I am, and most people aren't, and you don't want to mess with this stuff, you just kind of set all this stuff up and you hopefully work with a good solar and battery consultant. And you just set it and forget it, and you're on your way and you don't have to worry about it. Like I enjoy looking at it, but I can assume the vast majority of people who we need to convince to use these things could give a shit less. I'll just say that. I'll just be honest, they don't care. But you can help teach people how to set it up and then how to just check it from time to time to see how it's performing. And of course, their utility bills will tell that story. Um, Now, when you're designing a battery system, you have to determine your power load ahead of time because you need to know whether you will have a critical load panel or a whole home backup. If you go with a whole home backup like I did, you need to manage your power outages. You can see that the app here tracks outages for how long they last, how many how many outages I got, and you can go in and get details during the design stage to determine, what you want to do for your battery system. Now, since my home is all electric, I pull the heaviest loads in the winter with the heat pump running at night, especially, and the EV car charging. That's my highest peak load. So if the grid went down, that load would be super overwhelming on my battery. Um, and so one thing I have to think about is there a big winter storm coming? And in that case, what I'll probably do is, keep an alert on my phone throughout the middle of the night and make sure to unplug my car or charge it later so I don't get this massive smash on the battery and it's drained out in the morning. Um, and then, and so someone might want to set up their critical load panel. They don't want to deal with all that. So they might just say, hey, my critical load panel only has other things, right? It only has cooking. It might have the refrigerator, whatever it might be. You kind of have to make that decision in the design stage of putting in your battery. Do you want the whole home backed up or just a portion of the home backed up? And there are now devices that are smart that you can install for your main breaker panel that will make those decisions in real time and stop the battery from getting overwhelmed if you want to have the best of both worlds, but you're going to pay for that. Um, so, in regards to like thinking this through in the summer, it's much less of an issue because I have much less of a load. And again, if I know a storm is coming, I can just back the car up in the day when the solar is shining, unplug it at nighttime, and have less of and most of my power failures occur thankfully mostly in the summer, whereas most do in many cases. So it's less of a worry here as well. But those are all things you have to think about. What is the power demand of your home improvement? Are you going all electric? You may need additional batteries and a smarter management system, especially if you don't want to be, your clients don't want to be dinking around managing all of this stuff. The other nice thing about this particular battery system is that when a storm is forecasted, it could be a windstorm, a rainstorm, a thunderstorm, a tornado, hurricane, which we don't get here, but not yet, someday. Um, it will back up the battery automatically on its own to 100%, and it will maintain that level, overriding your time of use setting just to make sure you have that power for resiliency standpoint. So resiliency was very important to me, and that was my decision of why I shrunk my solar down and instead included the battery system within the house. And I would argue, and I see most of the time nowadays, solar systems and battery go hand in hand. You certainly don't want to get one without the other anymore. Um, so speaking about outages, before I got my battery and solar installed, but after I installed my radon system, so there was a gap between my electrification project in November 2020 and my solar project in February 2021. We had a long power outage, right? 3 days long. It was a pretty bad one. And when the power was restored, I noticed my air quality monitor showing a sudden radon spike. I went down in the basement and was able to see, unlike in this photo here, that these two lines were even on the radon system from the inside. There's what it looks like outside, there's what it looks like in the basement. But those pressure differentials had become even, meaning there wasn't a pressure differential anymore. And I didn't even know that. Nobody trained me or educated me on how the system worked, and shame on me for not asking the question. So I had to ask, what's going on. I had to call the radon installer. I kind of had to learn about what it meant. But what I found was that the breaker had tripped and it caused the system to shut down. And the reality is I don't think the vast majority of people in homes with radon issues who have these active systems are ever going to see that or check that. When these things are buried deep down in the basement or the crawl space, it's out of sight, out of mind. If you don't have a home energy map app telling you your radon system turned off, that could be another way to know. You don't know. So this is another reason why I can't overstate the importance of our air quality monitoring system. I would have been exposed to high radon for a very long time had I not had this radon monitoring system in place and had not known about it. And now in my case, I also now have a battery system which may have prevented likely that system from going out. But I will tell you, even with my battery system, there's a 1 second flash. All the lights flicker and flash and the power goes out for like just a second before it kicks on. And so even then, there's the risk of a system shutting down, though I will say never has a breaker shut down before or since then. So I'm guessing there probably was during that outage several years ago a power spike that caused that. And now actually I have a system in my home that my insurance company sent me that even looks at the quality of my power and whether the grid is causing me brownouts or power surges. And we recently had some power surges happen from the grid. And so these kinds of reporting, these data information help you keep your systems running and help people understand to keep people safe and healthy. And that's why we should have these types of systems in place, in my opinion. So in summary, you can see my pre and post energy improvement for my house. And using the DOE Home Energy Score, you can get a forecast of what the project will use and kind of give a nice little snapshot of what someone could save if they're using this, if you're using this as part of your project assessment, evaluation assessment. The HERS index rating, the ERI, does this too. I imagine someone who knows how to use Passive House is going to give you something very similar, whatever it might be. But it's a nice little kind of pre and post evaluation of what's going on. Now, so like I said, February 2021, we got the solar and battery. That sort of completed the project. As far as I know, project was over. But immediately following the addition of my solar and battery system, an unexpected event occurred where my fossil gas powered car broke down, one of them anyway. And so I was again lucky, unlucky. It's like, well, this is a good excuse to electrify or get as close as I can. I was able to acquire a used 2017 Chevy Volt with a V, not a Bolt with a B, which is a plug-in electric hybrid, which uses half gas. And then in the summer 2021, I added this nice little level 2 smart car charger, which lets me charge off peak at night when rates are low, carbon emissions are low. And even though all my energy planning, it's threw a whole wrench in all of my energy models and planning, right? Because now I have this massive electric load on my house that I didn't have before. And just, looking at the data I have, we're probably at about 25% of my total electric and total, I don't have any gas. So total home consumption is a car. And that's about 4,000 kilowatt hours a year, additional of electric demand that I didn't forecast. And I was able to use my car charging app, which gives me real-time data, and use my battery management app, which gives me real-time data, my Rheem heat pump eco.net app, which gives me real-time data. And I could come up with kind of this assessment here of typically how my home has been operating and using energy, as of 2023. Is this where I got this data from? Is when I really did my evaluation. The other thing is, while my electric bills shot way up because of my electric car, my gas bills plummeted, and in an end, when all things are said and done, I'm saving about $100 a month in gas costs by switching over to a plug-in electric hybrid. It would have been even more if I would have went all electric, but just couldn't afford the full electric car at the time. The other thing I wanted to show you here briefly is just my total electric total energy consumption, MMBTUs, from before I did my improvement. Almost 22,000 kilowatt equivalents. So we converted the kilowatt hours or the therms of gas over to kilowatt hours. So this is almost 22,000 kilowatt hours of converted gas from gas to electric usage before I did my project. Total operating cost before I improved my home, $1,300 a year in gas and electric costs. And here's my what the home energy score said I should have been using. Not far off. Um, Fast forward to 2023, I've added about $1,000 in costs. But you got to caveat that with a couple things. Number one, this is including 3/4 of my total travel costs. It's a PHV car, so I still have some gas costs, and I have another gas car that I barely ever use. So there's still that factoring in. There's still those, you know, that being factored into this cost, putting that load on my house. But the other thing I wanted to show you is again, the home energy score. Here's what we predicted we would use. And here is what we ended up using if you back out the electric car and back out all the solar. So pretty close, pretty accurate. And, it's just important to know that hyperinflation of our energy costs is, yeah, I did all this stuff and now I'm paying more. And so you might say, is it worth it? You did all this stuff and now you're paying more money. And the fact of the matter is, if I hadn't done all this stuff, I'd be paying even more money because of inflation. And so it's definitely worth it. And to me, it's about health and keeping myself and my family healthy, about doing, putting my money where my mouth is, and about reducing my carbon emissions. So unfortunately, this tool doesn't exist anymore from our good friends at Watt Carbon, who you should check out. But they had this nice little tool where I could upload all my data and it would give me a breakdown of what was going on. So this is year 2023. You can see how carbon intense my house was across the year and across the hours of the day. And so you can also see, what the mix on the grid was throughout the year and, what my carbon versus, non-carbon resources were. In the end, we had about 18,000 pounds of carbon. That includes 3/4 of my travel. It's not including my gas car consumption, my gas travel, but it includes my electric travel. Now, take that and consider where I was in 2017 when I had methane gas. I had almost 7,000 pounds of carbon being used. And that's just the gas. That doesn't include looking at the carbon being emitted from my electric consumption or my gas cars at the time. So you can see just a massive reduction by switching from to electric systems and adding solar. I mean, I added solar as well. And so that's, important to me. It's not important to everybody. It's rarely important to anybody, but that's an important thing to me and for those who want to reduce their emissions and also, helping stabilize the grid, we need to make sure that our energy use is occurring when the grid is the cleanest and when there are resources available on the grid. So one thing that I'm proud of is that I financed my project um, primarily by leveraging traditional mortgage products, including refinancing and a construction loan available to all with minimal rebates and incentives. I did get lucky that during COVID, the mortgage rates crashed. So that helped me be able to refinance and thankfully, as of this webinar, those mortgage rates are starting to come back down, again, helping more people use the standard loan construction process to refinance. Now, there was a 23% tax credit on solar back in 2021 before the Inflation Reduction Act. But thankfully, I wasn't counting on it. It wasn't something I needed. I wasn't sure I could even get it. And so I didn't even factor it in to my decision-making process of buying the solar and the battery. And so I think that's very important because as of where we are today, the home's 25D tax credit of 30% is expiring at the end of this year. And if you look at the news as of this recording, there's really no indication that there's going to bring anything like that back anytime soon. So it's important that we proceed forward with market rate options. I know it's painful. I know it'll have harmful effects, but we need to have tools at our disposal that are conventional for all to use to finance these types of things. And so, my financing journey was not without its challenges. My first attempt to use a construction loan required hiring a licensed builder, and then requiring and you know that really just didn't make sense. I just didn't need a licensed builder on my project. It was just unnecessary. So one argument I make is that if you're going to put um, mortgage interest rates and home energy mortgages contingent on your lending, and I'm saying this to all you lenders out there who, uh, you know, put other options than having someone who has to be a licensed builder. Maybe having a green home inspector, right, as also an equivalent to being a consultant on a project to get those lower mortgage rates when someone doesn't need a builder, or a certified HVAC contractor with our good friends betterhvac.org, whatever it might be. We need to think through a little bit more than just the licensed builder being required to get that interest rate. So that was another one of my barriers where I could have got an even lower rate if I had hired a licensed builder, but they would have charged me a lot of money. Um, and so I explored the Freddie Mac Green Choice Mortgage Program, which is still out there and I still highly recommend it. And that required the Green Certified Rater and Green Appraiser, which I got involved in my project anyway. And I, worked with United Bank of Michigan, who was very grateful to, work with to help finance and come up with some unique planning process. They helped me find the right appraiser to do the green appraisal process, which was very crucial. And so we were able to get the green appraiser to consider the energy savings, consider other local green and solar properties in the area. And that enabled me to borrow more money to pay for the project during my refinancing. However, it's important to note that the appraiser was not able to recognize all green home improvements. And, part of the reason for that is because they couldn't find proof of those comparisons in recent homes that had sold. Um, throughout the process of getting the financing, I had to prioritize and adjust plans based on the appraisal outcomes and available funding. So for instance, I reduced the scale of my solar installation as well, um, to meet the borrowing limits without incurring excessive appraisal fees. And ultimately, the funds were used to pay contractors directly, and the project was completed, within the budget. I think the experience highlighted the importance of working with knowledgeable lenders and appraisers, as well as really the ability for our traditional construction loan financing programs that are out there. Um, and I wanted to say a hat off to my lawmakers who had recently just passed an act here in the state of Michigan that prevented my tax assessment authority from being able to tax me more in my property assessment for the solar and battery and green home improvement. Every state should certainly pass a law, like that. Um, so again, I think the standard mortgage rate is great, but I will show you here in a second why we're planning on using something different, for my next um, project. So, one of my biggest regrets and lessons learned and trade-offs in hindsight was that I opted to update all my lighting to motion sensor lighting because I hated seeing lights being left on. People forgot to turn them off. I'm equally guilty of such things as the rest of my family, or people who have they come over. Um, and so, you can just, right, you can see the energy waste. So it really bothers you because you can see it. But I quickly saw that because I have all LED lights, mostly LED lights, when I looked at my energy management system, um, I could turn on all the lights in my home and it just never would register once, um, at all. So it didn't even make a difference. Um, and so I spent, all this money upgrading to these motion sensors, which work great, but I have to get special lighting that work and some of them flicker if it's not right. So, conversely, looking at my energy management system, the condensing dryer I got does register on the monitor with huge loads on my system. In addition, it overheats the house in the summer by putting so much heat in the house, causing the heat pump to work harder to run. And, it's just, overheating our home on really hot days. So in contrast, the pretty much the same amount of money I spent on the motion sensors could have been switched over to getting a heat pump dryer instead, which would have significantly reduced my power load, my peak load, and it would have stopped me from overheating my house. So that is one of my regrets right there. That, was just where I invested my money connecting the two dots together. We all have limited budgets. And so at one point I, hit the cap, didn't want to invest in the heat pump dryer, and I should have done it instead of that motion sensor lighting. So my my next regret was not getting a dehumidifier as part of my 2020 home improvement plan. It would have been more useful than the humidifier, and I think as one of you pointed out, you shouldn't need a humidifier in tight homes. But again, the home isn't super tight. Um, but I probably should have traded the dehumidifier for the humidifier in hindsight. However, in the year 2022, I decided the time is now because I have some concerns. Um, and really, I should have known better because I was tracking my humidity and dew point going back to 2019 and showing clearly high humidity levels and dew points throughout the late spring and all of summer and halfway through fall. I assumed my heat pump would dehumidify the basement on its own, being right sized, but it never did because what we're finding out now is that these high efficiency heat pumps and air conditionings, to be fair, with these high C ratings come at a trade-off of their ability to also dehumidify. So I learned that in real time. I ran the numbers in this dew point calculator here. That's pretty cool. And it gave me my risks of mold and damage to mechanical systems in my utility room, which is where they all are, and in my mechanical closet, which is in unfinished space, much more, has higher air leakage in it, colder drafts, and it had an open sump pit. While the sump pit remains dry from rains, it draws up a lot of moisture because all my condensate lines just dump right into the open sump pump pit. So that's another humidity concern that I added to the house even later. And so you probably hear that noise right now. Uh, One of the things about this dehumidifier is that it was very loud. So, again, looking at the sound quality of it, one of the downsides to bringing it in, one of the negatives for health is that downstairs in the living space, if you're adjacent to it, because I have to keep the door open for cats and heat pumps, it's loud. And so it does degrade the sound quality of the house, and that's an unfortunate trade-off. The other unfortunate trade-off of this system, as you can see on the left side, you can look at my kilowatt usage before, about a base load of 0.5. Um, Sorry, it's going to keep running that sound. Um, but uh, about a base load of 0.5, and that should stop any second. And then about 1.1 or 1 once this is running. So you can see the base load here, and then it updates here. So it does increase my electrical draw, it increases my base load, and it raised my utility costs to run this thing. But overall, it was effective. Here is the adjacent room, which we had high utility or high humidity and dew point in, you know, went down significantly lower. Now let's take a look at mold risk and indoor air quality I put an indoor air quality monitoring system in my utility room, and I put that in about a year ago. And so you can see starting in June, the humidity in the utility room started to elevate significantly, which it does in the summer. That's normal, but it never went back down. And one thing about this monitor that I really like and that I don't want to know, but I know, is that it gives you this mold risk, which, I don't want to have any mold risk. I don't think anybody does. So you can see I've got now a mold risk of 1 in my utility space, 1 out of 10. And what happened was maybe during one of those fluke power outages, I think, it tripped the breaker and it knocked out the dehumidifier. So I just the thing just runs on its own. It's a smart system. You don't need to think about it. But after a while, I'm like, it doesn't seem to be working. And you know what? I don't hear it running anymore. I just thought I was getting lucky. We're having a dry spell here in West Michigan. It's been super dry, severe droughts. I'm just like, maybe I'm just getting lucky. And so, when I started looking back at my monitoring app, which the battery had died on, so I wasn't getting some data on for a little while either. I had to change the battery. I just saw this consistent humidity, this mold risk. So I went down and looked, and yeah, the breaker was out, but also there was an issue with the dehumidifier, and we needed to have an HVAC come in and do a quick service. So once we did that, you saw a quick drop in the humidity and it stays low. Um, and so, it worked. But you can also see these dehumidifiers put out a lot of heat. And so, it put a lot of heat into the basement and, raised the temperature as well. So, if I were to, we're looking at ducting the dehumidifier so that way it can dehumidify the whole home. Right now, it's just in the space. We're just would be ducting the exhaust air only and putting it into the return, I believe, is what the schematic showed. But that's expensive. It's very expensive to do, and it creates this quirky thing in my utility room where there's this duct going over my head when I'm trying to get back there. So it's like, what do I do with this, Um, and so I almost wish I had gotten a ventilating dehumidifier um, instead of an ERV. I kind of wish that. I don't know for sure, but I definitely, think about it from time to time. There are trade-offs, of course. Obviously, someday, hopefully they'll invent a ventilating energy recovery ventilator, a dehumidifying energy recovery ventilator that is cold climate certified, that, does it all, right? Kind of a magic box. I heard about these coming. I don't know, but that would be, probably the solution because then I could, ventilate and dehumidify the whole house at the same time. All right, so what's next for me? If you didn't know this, there is a tax credit expiring at the end of the year for new doors. I think it's like $250 a door. My doors are in just terrible shape. Again, part of the bad water management system on the house. And they're metals, so they don't have that great of an R value, and some have glazing in them that I don't really need. So I will be upgrading to Energy Star certified um, tax credit qualifiable doors here very any day now. And that will also, we're going to do the trim around the door so it air seals the house even better and reduces some of the air leaks. And it's fiberglass, so it's just going to be real nice, real energy efficient, and reduce the entry point of my house, which would get super cold in the winter. You could just feel how cold it was. So that's a win-win. Also, finally, the roof is coming to the end of its life. So getting a new roof with some lighter shingles that might be a little more reflective, which does come with a trade-off of moisture management, but we're not getting the super reflective kind. They're not even available in Michigan. It's just got a little bit of a higher reflective value because my house does get a lot of sun, which is good for solar, but overheats the main room in the summertime where there's a lot of glazing too. So it will help keep that down. And of course, we'll get, a lot of the flashing issues that weren't fixed that weren't, done during the construction. All that's going to get fixed to improve the water management and durability. Also, the best time to do solar is, of course, yesterday and always. But the second best time is during, your roof replacement. Obviously, you don't want to put solar on a roof that's going to be replaced soon. So I did. And so, the current solar panels I have will have to come down and be re-added. That's fine. I knew that would be the case. And so then while now we're gonna, we're lining our project up to do the roof and then immediately put the solar panels back and then add east and west facing Panasonic solar panels as well. And so what will be nice about, and I'll be working with the Green Panel again, who I was very impressed with their work here in Michigan. Um, and that will essentially put me in, according to their modeling, net zero in May, super net positive in June, July, August, and I would bet we could get September too. We're going to work on it, but this is what their forecast is, for the house, based on their results. And then you can just see in the assessment they did for me, they kind of forecast out what your current utility bill is and what your new one is with just the new solar added. And I don't know about you, but they you can't see this number up here, but it is getting into like they're forecasting utility rates to be at the rate we're going. They're saying I'll be paying, if I didn't do solar, maybe $10,000 a year. Now, 7% escalation, you know, of electric rates, I don't think that's far-fetched. I think Michigan is averaging, maybe 5 to 7%. It has been over the last 4 years. So it's scary because the reality is, I think, who knows what's going to happen in the future. But at the way we're progressing right now, without a major systems change, we are going to be having unaffordable electric rates. And I don't know how to deal with that other than to add more solar, which will also reduce my carbon footprint and, make me more resilient, where I assume we're going to have more extreme weather in the future as well. So, this is important to do, whether this ends up actually happening and my utility bills truly would be $13,000 a year. I don't know. And I don't want to know. Even 5,000 or 6,000, what they're predicting with the solar, is expensive. But, it's certainly a lot less than 10, but it's, triple what I'm paying now. But that seems to be the scary future that we're heading toward if we don't make drastic, thoughtful improvements, um, to our homes. So, with that, I wanted to thank you all for coming over to my house here virtually and listening to my tour. Like I said, on the GreenHome Institute's website, on our blog, I will be doing more updates about my project, energy savings, cost savings, what I do, what decisions I make, probably doing more trainings and webinars around it. I know there are lots of things I still want to do to my house, like boring things like getting carpet away from the slider door. So because you want to make sure you don't have carpeting near entry for moisture reasons, just all those things like that to try to progress up to the higher levels of certification for GreenStar. I'm putting together a homeowner's operation and maintenance manual, which is also a GreenStar silver level requirement. And I'm still working on that. 5 years later, how do I put this together and put it together in a way that's helpful for others, trying to put together an operating manual for their own home? So those are things that I'm, working on in my house as well. So thank you for joining us. Thanks to our board of directors, our volunteers, our nearly 500 members who support our work, and in our 25-year anniversary, and all of our sponsors, as well as the American Solar Engineering Society for having me and many of our homes on their tour. A big thanks to them and, all of you for joining us.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.